started.
Sounds good.
Okay, so we're going to start with, have you heard or seen of the unit circle?
Yeah, that was the last thing we did.
Okay, so I'm going to actually snip in a unit circle first quadrant.
Okay.
And that'll help a lot here. I'm also going to send you a link to a reference sheet that I really like here in the chat. I would print, if I were a student again, I actually would print this out. I find it's incredibly useful. It's got all the stuff you're going to see in trigonometry. And then, but we're just going to focus on the first quadrant here today. So,
oh, wow.
There's a lot here, but don't, look at it later. You've got it there printed out. It'd become more familiar. So, so X is the cosine and Y is the sine values.
Yeah.
Okay. So like each point on the unit circle is a point on the graph that we're going to see. So the main points though actually occur at the 90s, and then the next 90 and the next 90 and the next 90 and so on. So I'm gonna graph sine, and we'll go from there. So sine starts at 0, goes up to 1, at pi over 2. Then it comes back down to 0 at pi, and then at 3 pi over 2 comes back down, and then at 2 pi it comes back up.
Got it. And that's like the parent, like sine X
sine
or whatever.
X. Yeah. And you need to know this, like, your phone number, like anything that's like really important. You gotta be able to wake up out of bed and say like, all right, I know what a sine looks like.
Okay.
This thing oscillates forever. It goes up and down, up and down, up and down forever.
Oh, okay. So it's like continuous.
Yes. And this is considered one period of sine. And as I mentioned, it matches up really well if you're looking at the unit circle and you're looking at, and that's on page 3 of that thing I sent you. If you're looking at the Y value, because the sine is the Y value is 0. That's the first one. The next one you care about is this one up here at 1. That's why we get this peak at 1. Then at pi, the Y value is 0. 3 pi over 2, the Y value is -1, and then it comes back.
Gotcha.
Okay, so we start with that.
So like, just a quick question.
Of course.
So I think my teacher, I wrote this down, said that we're going to need 2 periods of sine on the test. Yes. At the time, I didn't really understand what that meant, but does that mean I just have to like do another 5 coordinates or whatever?
Yeah.
Let's continue it.
We can build that into a question here. Let's do our first question.
Okay.
Let's go y equals sine 1/2 x. We'll just graph this. It's a very basic thing. So the way I graph it will probably be different than what you see in class, but maybe pick and choose what you like and don't like. The very first thing you need to figure out is the period, which is related to your question, which is like, how do I graph 2 periods? So the period is 2 pi over b. And what is b? B is the number in front of x. So in this case, your b is 1/2. So it's 2 pi over 1/2, which is 4 pi.
Okay.
So when you're graphing sine, and this is my approach, is you make a mark at 1 period. So we'll call that 4 pi.
Okay.
And then you cut it in half. That's 2 pi.
Okay.
Then you find the first midpoint or average, and then you find the next midpoint or average there. Sometimes they're nice like this, sometimes they're not. Then you repeat, you go out another pi, or no, I'm sorry, another period. So this is 8 pi, and you do the same thing. Now this one's this one's fairly straightforward because there's not any weird shifts, but you have to be able to label these points. What is important is the points being labeled correctly, not where they are relative to the grid positions. Like you've got to get away from thinking, oh, it's 1 unit, so it must be 1 unit. It's pi in this case, or it could be something else. Okay. So, and the reason is without doing any other transformations, here's what sine looks like in this particular instance. There's 1 period. See, remember how it starts at 0, goes up, comes down, and comes up. And then we do the same thing here. It
Oh,
goes,
it just keeps going because
it
it's continuous.
repeats.
Okay.
So if you can graph one period,
Then
you
you
can
get
graph,
the other one.
you have two periods.
Gotcha.
There's also some things that I like to do that vary from what you're going to see in the classroom. Like I tend to only graph positive. And if you transform left, we can do some things to make it look positive. Like your instructor probably won't specify which two periods they want. But they might, like they might say, I want to see something left of the axis, y axis.
Oh, so you just go negative?
Yeah, but it gets a little
Okay.
awkward, weird, and so on. Okay.
Oh, okay.
So there's, and you learned this from a previous class, there's a bunch of transformations that you're going to see here. One is related to the period, and that's your horizontal stretch and shrink.
Okay.
Do you use Desmos at all? Have we done that yet?
Yeah, we've done Desmos.
Okay, that'll help with like seeing this, but we'll get to that.
Okay.
You're also going to see you're also going to have what are called phase shifts, and these are like inside the parentheses of X. Phase shifts are like this.
Oh, when you add something?
You move, you translate left or right, whereas these are the stretching and shrinking are like pulling and pushing. These are literally like pick up the point and move it. So these are left,
like left, right,
like
up,
this
down
in here.
maybe?
Yeah, well, not up. We'll get to that one. That's
okay.
The third one is vertical stretch. So these are what you're going to see. And then the fourth one is reflection.
Okay.
Over the X axis. You can do it over the Y, which is kind of up here. We'll get to that. And then there's also up and down.
Got it. Okay.
Now, like when you're learning this, we don't want to do too many of these at a time, but like you should be expected, like you're like the ascent here is to be able to do any number of these and be able to graph it and graph two periods.
Yep.
Okay, so let's look at another example here. Let's go y equals -3 sine pi x. So the first thing that I want you to be able to do here is be able to determine the period. And the period is always 2 pi over b. And b is the number in front of x.
Oh, so this time it's just gonna be 2.
It's 2. And you're like, well, that's different than before, but it's kind of the same. Now, you can choose to compress this into 2 grid spaces, or you can arbitrarily choose where you want 2 to be, because I'm not pre-assigning these. Like I like to put 2 out here. But if your instructor gives you a piece of paper that says that's 2, then you got to go by that 2. But what I'm saying is like don't limit yourself. In the real world, we don't do that, but in classrooms we do. And you need to find the midpoint. Then you find the next midpoint. Then you find the next midpoint.
Got it.
And I like to, and this is my preference, I like to draw the parent function after I do the period. And then you'll see what we do next. And I'll switch colors here to do that. So the next one is this 3. What does this 3 do from previous functions? Do you remember?
It's gonna like, it'll stretch it, right?
It stretches. So it pulls up your Y value. So there's, let me do this differently. Let me do it in red. So these are the 5 points that you're going to manipulate. So this 3, this multiply by 3, what it does is if it's at 1, it's going to pull it up to 3.
Oh, okay.
Zeros stay the same though, because if you multiply by 0, nothing happens. But -1 goes down to -3. So notice if you do the transformations, and you'll eventually be able to do these all at once. That's the next transformation.
Okay.
Then the negative, that's a reflection over the x-axis. This is the x-axis. So everything flips. So this point up here is down here.
Yeah.
The ones on the axis stay. This one down here is up here. And it looks like this.
It's like the opposite.
Right. Now, I have colored pencils or whatever, colored digital things. You may want to make separate graphs for each one of these. You may want to combine as many as you can. This wouldn't be gradable for me if I were grading your work. I would want to see more, but because we have this, we can go out and do another period. So that was 2. Now we're going to do 4. Find the midpoint, find the next midpoint, find the next midpoint, and it just repeats. So now it goes, and you can get the point if you want here, but it goes down and back up. And if yours doesn't look exactly like mine, it will over time. Like these actually, bend back down nicely and smoothly.
Yeah.
Things like that.
Got it.
All right, so let's look at another example here, and then maybe we'll switch to cosine. Y equals 2 sine x minus pi plus 1. Okay, so the first thing that you find is the period. Period, and I'll say this over and over, it's 2 pi over b, because you got to know that. The number in front of x is 1. Okay, so this is 2 pi over 1, which is 2 pi. Okay. But you also need to find the phase shift, and it's really important to find the phase shift. So the phase shift is pi right. Pi right, and it's because of that right there.
Got it.
Okay, now I kind of lied to you. You don't start at 0, you start at the phase shift. And in all the problems we've done so far, the phase shift has been 0.
Phase shift's been 0. Got
so
it.
That's why we've been starting at the origin, but you don't start there. So you start at the phase shift. The phase shift is pi. I'm going to arbitrarily make that pi. Like I chose that. So where is 2 pi going to be to the right of that? Well, that puts you out here at 3 pi. So you start with the phase shift, but then the end of it is your phase shift plus your period. And those should always work out nicely, meaning like you're never like adding pi and a whole number or a whole number and a pi. Like they have to be kind of the same type. So like I've just it's really compressed here, but like this is your midpoint, that's 2 pi. Then we got another midpoint, another midpoint, and this is where your sine starts. So it goes up, down, and up like that.
Okay.
So there's this point here, and there's this point here, but there's actually 5 of them. Let me do it in red again. That was good. There's that left bound. I don't know why these aren't coloring in right. You need 5 points for each period, each period. So then, like, you're good enough math student, you should be able to do these 2 transformations together. The first one says you multiply the y value by 2, and then you add 1. So this one, when you multiply the y value, which is 0 right here at pi, when you multiply by 0, that's 0, but then you
goes up 1.
Right.
And then that one will be like 3.
It'll be 3.
Got it.
You got to be careful, because things change especially when you get negatives. Okay, so you multiply that by 2 first, and the reason it's by 2 first is because that's how you would evaluate this thing. It goes to -2, but then you go back
to -1. Yeah.
Right. So you're actually like the same spot. And then similarly here, this gets you to there.
Oh yeah, that makes sense.
Okay, so there's your period, but hey, you got to go out. You got to go out another one. So we got to go out to 5 pi. And it's up to you if you want to label the points. It's just got to look the same. You can see it hits these points. You go up like that.
Okay.
All right, let's look at cosine now.
Oh yeah, this is the one that was more confusing to me.
The cosine, it follows the x values of the unit circle. So it starts high because at 0, cosine of 0 is 1, but it goes low. Okay, so it starts high, goes low, then it hits here and comes back up.
So it's like kind of like the opposite of it almost.
Well, it's okay. So the truth is that there's only one trigonometric function but we say there's more than one because it's convenience. A cosine is a shifted sine, and a sine is a shifted cosine.
Mhm. Oh, it's like if you like subtracted one or added one inside of the parentheses, kind of like.
Yeah, let me show you exactly, since we're not in a rush for time here.
Yeah.
Let me switch to that screen. So the if we graph sine x, okay, you're seeing my Desmos here?
Yeah.
Okay, and if we graph cosine x, okay, they're not the same, but if I move cosine, which is blue, should we move it right or left?
Either one should work, right?
Yes, the answer is yes. Either one should work. So it's that, or if I go plus 3 pi over 2, I get the same thing. So
Got it.
like you, I find all this stuff really fast. I find like the more you understand, it's more fascinating, because like, wow, like there actually isn't that much in math, because they're actually the same. Like we just, by convenience, we show.
We have like another sign.
Yeah, and cosine's pretty convenient to use. It's not like you're going to get away from doing it. It's like, you don't add when you can multiply, but like, let's not pretend like they try to hide this, especially from you good math students. You really should know these things right away. You shouldn't be told things that aren't true, and they're really the same, but you have to be comfortable working between them. And you'll probably get a problem on your test, like graph this with a sine, graph this with a cosine, and when we get there, you can do that. So again, there's kind of these 5 points that you need to know, and they're always the same. Starts high, okay, goes low, comes back up. 2 pi is the period for sine and cosine. All right, so let's do a couple examples here.
Okay.
Let's say y equals negative cosine 1/4 pi plus 2. So again, the first thing I always want you to do is think period. What is the period? It's 2 pi over b. B is the number in front of x. It's 8 pi. Does this have a phase shift? The answer is no, because there's nothing else going on inside here.
Wait, is the pi in there? Should that be an x?
Sorry, yeah, that's an x. Thank you. Yeah, that's
No
actually.
problem. I was a little confused for a sec.
Let me check to make sure I didn't fumble up another one here. No. Okay, so there's no phase shift, which means you start your graph at 0.
Okay. And you just put out to 8 pi or whatever.
Yeah, and you can arbitrarily choose whether it's like you can make that 8 pi, or you can like be like, nope, I want that to be 8 pi. Like, it doesn't matter. You get to choose. Where do you want to put it? Do you want to put it here, or do you want to go out further? What do
That
you
should
want
work.
to do? Which one?
Probably just keep it early on.
Okay, so 8 pi, you got to find the first midpoint. You got to find the second midpoint. And I'm really bad at labeling these things, but like you should be labeling the X and the Y axis also.
Oh
So,
yeah, I haven't done that yet.
Yeah, I'm very negligent on that. Now, what we've taken care of when we graph this is all we've taken care of is the period. We've not taken care of the negative or the 2. I strongly recommend you at least get the parent function down before you move on to the other stuff. Okay, so the other one here is, and we'll do this in blue, you negate the Y values. So if it's positive, it's negative. If it's negative, it's positive. You can see it's actually just a flip of this. Okay, like it's a reflection over the x-axis, but then there's this +2. So you got to move every point, new point up to.
Up to.
Right, so it goes there, that one goes there, there, and there. And again, like you got to be clean with your drawings. Like, don't draw straight lines. It's got to have some curvature to it. If you're not artistic, you got to just try. You don't give me a triangle.
Yeah.
Effort, just a little effort, please. Okay, so that takes care of this, but then we can go out one more period. That gets us out to 16 pi, find the midpoints, 12 pi, 10 pi. And I call these jumps. The jumps are always the same. And we'll talk about that with maybe some harder problems, but it's going to have the same shape. It's going to go up, up, down, down, like that.
Gotcha. Okay.
Do you have any homework problems that we can look at?
Yeah. Can I go get my book real quick?
Of course. Let's spend a little time doing those, though. You can potentially verbally tell me, or of course, send some pictures if you want us to look at a block of questions.
Okay. Oh, what would happen if it's like an absolute value? Like, would that ever come up?
Yes, in your class it would.
Oh, geez. Can you go over that?
Of course. So let's just do y equals absolute value of sine x. Is that what you're referring to? Something like that?
Yeah.
Yeah. So you start by graphing the parent function. And of course we can add in like, you know, shifts and stretches and flips and all that stuff. But let's just like go with the basic one here, which is sine starts at 0, goes up, comes down, and comes back up.
Yeah.
Okay. So as a reminder here, if I asked you to graph y equals x, you would graph this. And then if I said, well, what about absolute value of x? You would say, oh, well, it's a v. And I would ask you, well, why is it a v? And it's because the negative becomes
positive. Yeah.
same thing here. So it bounces.
Oh, so it just goes up and down.
Wherever it's negative, it's positive. Wherever it's positive, it stays the same.
Gotcha.
You may also see, I know this is a real aside here, but you probably saw this in like, you were asked to graph something like 9 minus x squared absolute value at some point.
Yeah.
And like that, you know, that starts up here at 9, it hits at -3 and 3, but then it bounces.
Mm-hmm.
So
Oh, yeah, because it can't go negative.
It can't go negative. So like whatever's negative, you just reflect up the other way.
Yeah, gotcha. That makes sense. Oh, there's one here. This one looks a little confusing. It says y equals cosine of -1/2 x plus 4, and the plus 4 is on the outside.
Okay. So as a review, if f of -x equals f of x, this is called an even function. And why is that relevant here? Well, like, let's look at y equals x squared. If you put -x in for x, you get x squared.
You get x squared.
And graphically, well, here's what that means graphically, because this is actually what you care about. The right side looks like the left side. That's what an even function is.
Okay. Yeah.
Okay. And so this property applied to here means the following: cosine -x equals cosine of x, which means that you don't graph this one, you do a rewrite step, which the more math you take, the more you're going to do this. You graph cosine 1/2 x plus 4. Now, rather than take my word for that, let's go back to our graphs here, and let's just look at it. Let's just do cosine, because I don't have infinite knowledge. I don't know everything, but you can see here this tool confirms what I just said.
Oh yeah, it's the exact same.
And let's put a K here, and let's add a slider, and let's let that thing move. Your graphs are exactly the same. Doesn't matter what number's in front.
Huh.
It's always that. So let me go back to the other screen, and we'll talk about odd functions, because that's something else that you might see. And then we can decide to graph this or not. Okay, so let's go here. And let's say I wanted you to graph y equals sine minus 4x. Sorry, 4 pi x. I'll just make it weird.
Okay.
If f of negative x equals minus f of x, this is called an odd function. So the first odd function that you know about, believe it or not, is y equals x.
Or because it's opposite on the, like across the axis.
It's a rotation symmetry. So it's exactly what you said, but it's called a rotation here, is what it is in truth, or point symmetry, because it's that origin is the place that it reflects. Okay, so why does that matter? Well, sine is an odd function. So sine of minus x equals minus sine of x. So you take this negative and you rewrite it here, moving that negative out. That negative comes out. And this thing that was unclear in the beginning becomes negative sine 4 pi x. So you never graph this first one. You always graph the rewrite, or you do the one that's there.
Got it. Okay.
Now, we didn't get into this thing. I think this is really important here. Let's say I wanted you to graph y equals 4 sine 2 pi x minus 4. No, let me make that a 1.
Okay.
Make that a 1. Okay. So the period is 2 pi over b.
The period's just 1.
No, it is, but there's a thing here that I need to do. This is not correct form. It needs to be written like this: x minus 1 over 2 pi.
Oh, shoot.
So you have to be able to factor this out if it's not factored out. Now, it didn't apply to any of the problems that we did.
No, it did not.
And you won't see anything quite weird like this, because this is really weird. But you need to know that this is not in the right form. So here's how it might be written. It might be written like this. Different example here. It might be like negative 2 cosine pi over 2 parentheses x minus 1.
Nah, x minus 1, like inside there is,
yeah, and we'll say plus. So here's what in this problem, your period is 2 pi over b. Your b is pi over 2.
So it's gonna be 4.
Your phase shift, which I'm going to go start writing PS, is this right here, this negative 1. It's 1 right. Okay, but that's because it's been factored. It has to be factored.
Yeah.
So if I give you the same problem and it's not factored, and this is your exam question, you'll see. Okay, and you'll get the period right, but the phase shift, you'll say, oh, it's pi over 2. No, it's not. And another kind of self-check is that, like, see how the phase shift and the period have the same, like, units, so to speak. Like, it's not pi, it's either with pi or not pi.
Yeah.
The period and the phase shift always have the same units when you're doing this. Now, if you get a pi here, you're gonna get a pi here. If you don't get a pi here, you're gonna you won't get one there.
Oh, that makes sense, actually.
Yes. So that's like a built-in check that, like, oh, that you feel good about your work when you turn it in. So when I was taking this class, I didn't have Desmos. I had a graphing calculator that graphed really slow, like yours do
Mhm.
now.
Yeah.
I would use technology as much as I could. Like if I had a homework problem that said to graph this one here, I would go right to Desmos and graph it first, so that I
Mhm.
know the target, I
What
know
it
what I'm
should
looking,
come out.
what it should come out to be, and then do the work if you know if that's required. But one of the limitations of Desmos, and I'll show you that right now, so you can get a feel for this,
Mhm.
is so let's pick something really crazy. Minus 12 sine pi over 2, I don't know, x minus 4, something like that.
Oh my
Okay.
goodness.
Okay, I don't know. You might get this. So here's what you want though. You want these nice points. Do you see how I'm clicking on these nice points?
Yep.
All right. And they're nice, like they're totally readable. But watch this. As soon as I like add something here at the end, sometimes they don't get readable. Actually, these actually are okay. But what I was going to show you is that sometimes this K value, or
Mhm.
this I'm sorry, this number at the end, it can impact your ability to do it nicely. So like if this were your question, what I would suggest graphing is this one first, and then like adding in this little extra part. Like make sure you get the nice points is I guess what I'm trying to say. Don't, if it looks
Don't
weird,
just do. Yeah.
yeah. So this isn't a
Okay.
great example of this, but I think
I get what you're talking
your
about.
tone is
Yeah.
due. Yeah. So like and so you can do some other things. Like let's say you're just seeing too much. You can make your period. So the period on this one is 4.
Mhm.
So you can force it to graph one period using these curly braces. And that might help. And you're like, hey,
Oh.
but I got to do 2 periods. So there's 2 periods.
Yeah.
Okay. And that could help. And see, the nice thing about Desmos is you don't even need to calculate it. Like if you know it's 2 pi over b and you just write pi over 2, it'll do it for you. So see how I didn't even calculate it? It's just doing it for
Oh,
me.
wait.
So like
Oh, shoot. Yeah, you
the
don't have to like do all the work then.
yeah, the computer knows this. And it's just help. It just helps you kind of like guide yourself through it
Mhm.
and get that.
Oh,
And if you want one
that's
more, you
actually pretty
just
cool.
you just put another 2 out in front. So, and like if you don't know what this is, you still can just go over here and say, well, let me just put a negative in front, and you get more of them. So
Mhm.
it's I don't know. All right. Have we covered everything you wanted to cover? Is there more you'd like to cover? What would you like to do?
That's about everything that I need to go over because
All
we
right.
just started this one.
Okay. If you'll indulge me here with just 2 more of your minutes, I'd like to
No
have
problem.
you look at something. I'm doing a little bit more on social media, and I always throw up the question of the week, but this is something I was working on this week. You see
Yeah.
a lot of these. Sorry, I'm having a high here. Let me get it. There it is. It's a question that you should be able to solve relatively quickly, and I just want to get your initial feedback on it. If you can indulge me and work that out, I would appreciate it.
Okay. It's like 107.
It is. You did that really quickly. What did you find easier or hard about this, if anything?
Um, Obviously the strawberries are really easy to figure out.
Right.
So then,
But then you get to this, I'm sorry, you get to this line.
yeah,
And what did you do here? Did you
I
guess this
just
number, or did you move it over and
I
like
did
what?
yeah, I added 8 to the other side and then
Okay.
divided by 8.
So now you get to this line, so you know that that's 11. This one's the one I'm really curious about. What did you do here? Did you guess a number?
So
Or
I
did you?
yeah, I thought about what would make sense. So like at first I looked at 11, but I knew that 11 times 11 is like 121.
Right.
So then I knew that wouldn't work. So I went to 12 and
Okay.
I found 132 and then minus 12. That
And
worked
then
out.
did you have to pause here at all and like, okay, do I add or multiply first? Because that's one of these questions are designed is like you add before you multiply.
Not really. I just like,
like this is the way it's supposed to be, but
yeah, didn't have much trouble on the last one.
all right. So have you seen anything like this before?
Yeah,
You have. And do you like them or not?
I do enjoy them actually.
Okay. Like you would actually pause like your feed and be like, oh, let me try it. Maybe.
Yeah, yeah, I do those. And I also like to read. Like, there's always comments of
Yes.
like what people are saying, and
People arguing.
there's a lot of arguments, and I always find that funny too.
Okay. So the email I send you got my social media stuff on there. If you ever have like a short question that you want answered before your lesson, I'll throw up like a 1-minute video explanation of it. And just like, and I won't even mention you except to say, hey, thanks for the inspiration for this. But I try not to like make it, attach it to you other than just, hey, thanks for,
Got it.
letting me help you out here. So if it's short or even if it's just a write up, I'd love to help you out. I guess that's it for tonight. I'll send Nico's mom a text and hope he's feeling better.
Yeah. Thank you.
You're cool. I'll see you next time. Thanks so much, Jamie. Have a great night.
You too.
Bye now.
Bye.